Hello friends, welcome back to my YouTube channel again, TechMake Navneet, and this is the last part of our Azure Certified Data Fundamentals course. In this part, we are going to discuss about data analytics workload on Azure, and I hope you are liking the way I am explaining the terms. So friends, my humble request again, kindly subscribe to my channel if you haven't subscribed yet. Hit the like button, share it with your friends, colleagues, and to whomever who can get benefit of this video. So quickly we will go through the syllabus of Azure Data Fundamentals course. So we have already talked about core data concepts in first video. Then we had part 2 for relational data, part 3 for non-relational data. All the links are available in the description box. Also in the same if you are viewing these videos, you will get the notifications of these videos also. And this is the last part, the part 4 of our whole course series, the analytical workload on Azure. So let's start. So what is workload, my friends? So workload is just the amount of work and load. From the name itself, it suggests you have some work and it's an amount of sequential work you need to perform. When it comes to ETL or data side, it is also defined in a similar way. Just it's a representation of a series of work that required to be done on a regular basis. So types of workload we will start discussing from here, and you will be understanding the workload in detail. So we have three main relational database workloads. So this kind of workload are usually representing the relational databases. Since, as we discussed earlier, relational databases are the earliest way to store the data on databases. Later we found the semi-structured data containers, the non-relational databases and all, but these definitions we will understand in terms of relational databases. So the first one is as a place to store business transactions as they occur, we call it as a OLTP. As a place to store data for complex analysis, OLAP, and a centralized repository for data from different sources, that we call it as a data warehouse. So we already have discussed data warehouse in the previous video, but again we will go through it in more detail. So let's discuss one by one. So first is OLTP, online transaction processing. So what does it mean? So most business applications require a place to store and retrieve the data. As business transactions occur, they are recorded to the database. Existing rows can be updated. Data can be retrieved by SQL queries optimized for general use. So a little detailed elaboration can be like, so online transaction processing, this kind of workload when we are storing the daily business data with whatever business is happening on a daily basis, in terms of bank, if the regular transactions, deposits, withdrawals, so the bank balance and all must have to be updated in backend databases, and not just to bank, like insurance industry, healthcare, even general store, supermarkets, everywhere. So whatever happening on a daily basis, and a school, colleges, universities. So any change in a state, so transaction, as we discussed earlier, it's not money deposit or money withdrawal. Transaction in a database is a change of a state for one particular entity or one particular row in the database. So daily transactions are storing the daily transactions and retrieving the data, because it's not just a storage, but you need to retrieve the data also for different purposes. And as business transaction occur, they are recorded to the database. Definitely there must be some storage which can say what kind of transaction happened today, what kind of business we did. and obviously since we are talking about the relational database, we are explaining the terms in terms of relational databases. So data have to be retrieved by SQL queries, and this is optimized for general use. So traits of OLTP: database normalization schema heavily enforced, strong consistency, heavy writes, moderate reads, updatable data size MB to TB. So updatable means the data has to be updated, means data the database, the workload should be designed in a way that the data, the value, let's say if again in let's not take a bank example, we are too much going into the banking examples. So let's say if you are just maintaining a data of a go down maintenance. So now previously it had stored 100 boxes, but 50 are used today, and now it is having 50 boxes for one particular product. So in this case, the count field, if we are storing in that way, the count has to be updated, so that if the store manager retrieve the data through SQL query or some user interface, even though the user interface, if you are just clicking get me the correct count or something, some queries are created in backend, ran over those databases and giving you the number in graphical in user interface. So the quantity and count and all has to be updated. Data size MB to TB: a small data can start from a storage size MB and it can goes up to TB. So you may see whatever traits we had discussed about relational, same are applied here. Then Azure OLTP services: Azure SQL Database, SQL Server in VM, Azure Database for MySQL, Azure Database PostgreSQL. So again, my friends, all relational databases, Azure relational databases are also, you can see here, if you remember, the same names are represented here. So all are designed to store OLTP data, online transaction processing. Again, in a one line, OLTP kind of workload when you are storing a data of daily business transactions. So next we have OLAP, online analytical processing. So what does it mean? How it is different with the previous one? So we will also talk about that. So data stored in a transactional database was not designed for complex analysis. Data stored in a transactional database can change at any time. Running complex reports can slow down a transactional database, can take time to prepare the data for analysis, queue dimension measures. So OLAP, when you are storing data in a way which is not for the business need of daily work, but it is used to create reports, do the analysis, and organizational level, the higher management level, when they used to do such kind of things. So let's take an example. So if I am let's say a store manager, if I am continuously I am updating the count of every single product, sales of every single product, how much I sold. So these and based on that we are updating the data, and we are also retrieving to check what is my inventory, how much I sold one product and all. And if it is being done by store manager, it is OLTP, online. Okay, and when this report is on a weekly basis or monthly basis being generated by some analyst to present the maybe area manager or some higher level, so from this store we are seeing this much of the sell for one particular product, while decrease in sell for other one. Even we are seeing some good profit for something and not for other. So that kind of things is being done, then those storage is called OLAP. Now you see, can not we do the same with the previous storage, the data which is stored in OLTP like Azure SQL Database and all? Why cannot we create a report from that? We can, but the problem is Usually this kind of reports, I am giving you a very low example. For creating such kind of report, it require a heavy query. You need to join multiple tables which all are hosted in different server. They may have different schema, or maybe you need data on monthly basis, weekly basis, quarterly basis. In that case, you need to run the big size data. Maybe you are writing your query in a way so that you are just seeing 10 rows, but in the query the calculations are heavy. So if you are checking the sales, total sale value of 10 product, you are in your SQL, the analyst has to write some condition so that it can add all the values and give a result as a cumulative added value. So final representation on the query tool is very less amount of row, but maybe the query has to go through a lot of calculations, and that may need to retrieve like hundred of like thousands or 10,000s or lakhs or millions of rows. So if you keep running such things in your normal database, it will slow down the process. So it will slow down, it will impact the daily transactions, it will impact daily business, it will impact the reporting task also. It will impact the performance at the both place. So it is always suggested to have a separate tables and a setup for OLAP while keep a separate for OLTP. So online transaction processing is happening regularly, and over top of it we can create another set of database which will store the same set of data, maybe same or maybe using some further ETL, but that will be separately used for analytic purpose. And this analytic purpose, it is like very common thing. If you take an example of any cellular company or something, so regular recharges, they are storing the regular recharge, daily consumption, internet, voice service, other services, while those data are being analyzed by some other person to see which kind of age group of people is using which kind of services, from where they are generating revenue, which service needs improvement, which service is in demand in some particular region, in other region what kind of demands they have. So this thing happen in parallel, and if you do from the same table, same database, it will slow down the overall performance at both place. So that is why we are creating another OLAP, means online analytical processing workload, over top of OLTP. So threads of OLP, no locking, no updates, heavy read only, multi-dimensional indexing, data size to GB. So I'll quickly go through it. So no locking means database is not required, data should not be logged. So if analytics person has to do some kind of data retrieval of using complex queries, and if any locking is there, that do not make any sense. Similarly, no updates, yes, this might be confusing you. No updates, so no updates means it's not like the data has to be rigid, but the updates must go through a systematic thing. For example, again, if analytics is making some predictive analysis for the, so already we have gone through this 5 kinds of analytics in the previous video. So maybe if I am an analyst, I need to create some predictive analytics. I picked some record and went through some calculations, but my time was over and I was not able to complete my work. I need to do the rest of the task tomorrow, and when I retrieve the data tomorrow, and if I see the data is quite changed, so again my previous day work has no meaning. I have to do the whole task again from the scratch. So no updates means updates should be a systematic. It's not like the way online transaction processing. The daily business transaction will not be recorded, but it will be recorded when defined, like in a period when the reports are already created and now we have to load the data for our next reporting. Heavy read, obviously we have talked, like we need to run the multiple queries, we need to retrieve a lot of huge amount of data. Multi-dimensional indexing means indexing we have seen, it just we create an index for a particular column, and if we are referring that column to retrieve the data, the performance increases. Usually we do this for on primary key, but that is not a correct definition. That is a usual approach, but index can be done on any other attribute also. Data size in GB, obviously, since this is not a daily one, but the large amount of data of maybe including some historical little older data is also required for reporting, so data size must go to over normal OLTP. Now what kind of services we have? SQL Server with column store index, SQL Analytics service, SQL Server Analysis service. So these all are the services which is in a way equal in the logic and appearance with this one, but these are designed to serve you in with this requirement. So you can also use this one as OLTP, but using this services as OLTP is more preferable, because these are designed to help you, to assist you with the way the OLTP required, and while these services are designed for OLAP. So next we will check data warehousing. So data warehouse, as we have also discussed earlier, it's a central repository for historical data, large amount of data from different sources. So this kind of data you need to store for reporting purpose, and if you need to store the data for a longer time, and somewhere in some of the businesses it's also government mandate that you need to store the data of your customers, your users for let's say 3 years, 5 years. So again, if we go to the example of bank, then bank has to store everything from day one, what customer has done the transaction and all. Earlier it was not the case, but now in days everyone is storing such data. Yeah, it's a thing. You cannot retrieve this data if you are logging into the system. It's still like some of the example like HDFC, it gives you the privilege of retrieving the data of last 5 years if you are from India and you have account in HDFC bank. Similarly, other banks also provide some kind of facility, but even if they are not giving you, means that if they are not giving this facility to end user, they have this data with them, because we don't know when they need to go and check the history of any user. So keeping those historical data like 5-year-old transaction, which will be very rarely used, might not be used, may be used for creating a reporting for like 10-year performance or yearly performance over different services, car loan, home loan and all, maybe, but maybe one time in 6 months or one time in a year. So those are supposed to be stored in data warehouse. And also it can be like, again there can be a ETL before loading to data warehouse. Maybe data warehouse is supposed to store in some other way. And also data warehouse is like in your regular database you are storing the data of last 30 days. So when you are loading the yesterday, means if you are loading the yesterday's transaction today, simultaneously you are striking out 30 days back data and pushing them to data warehouse. So Azure services are symmetric multiprocessing, SMP, Azure SQL Database. Yeah, you can use Azure SQL Database as data warehouse. SQL Server in VM, same, which is supposed to be OLTP. You can use the same service here as a SQL Server in VM. Massive parallel processing, MPP, Apache Hive, Then you have interactive query, live Hive LLP on HD Insight. So from this list, this one, Azure Synapse Analytics, is Microsoft own product, or better to say Azure specific product. So earlier it used to be called SQL Data Warehouse. Now they have rebranded this service as Azure Synapse Analytics. So these are the services provided by Azure, Microsoft Azure, for data warehousing. So when to use a data warehouse? When queries are long running or affect day by day transactions. Yeah, as we discussed. So if queries are long running, you are retrieving large amount of data over very complex logic and all. So if queries are running for 2-3 hours, that may affect your OLAP, OLTP. So better to keep them in data warehouse. When data need further processing before it can be analyzed. So let's say you have stored the data by some ETL, but again for different kind of analytics, to create a yearly report or something, again you need to transform the data so it can represent other aspects of the data. So if a further processing required, so in that case it's better to like put a ETL after your OLTP workload databases and store it in somewhere. So store it in data warehouse, and there you can directly source the data as per you need. When you want to remove historical data from day-to-day service system, so same example that I gave you. So like when you are loading today's data and you want to have only last 30 days data in your regular database, so strike out the data of 30 days back and move them to data warehouse. When you need to integrate data from several sources, so it's also like you are processing one area, but if your business has different business unit, different segments, and they have different own way of storing the data, but creating a cumulative report of your overall business, and in that case you need to store the data from all those sources at one place. So that can be also be done here, data warehousing, storing this data from different sources at one place. And also it's very useful, Power BI, you can directly integrate Power BI for data to your data warehouse, and you can create very interactive data visualization. So Power BI is data visualization application. You can ingest a huge data set and you can find some data visualization in terms of pie charts, different kind of, so we have n number of options. So Power BI is service, different service than the Azure. Also you can have a certification in this Power BI. So Power BI PL900 I am talking about. So but PL900 is not only about Power BI, it's cumulative 4 services are there as part of Power Platform, Power Apps, Power BI, and Power Automate, and I'm missing the one name. So that is a different course. However, we will see a little about Power BI in today's session. So if you want to have a certification there, if you want to learn down the line, I'll create a video series for Power BI Power Platform also, and you can earn a free earn the certification at no cost in free. And for that also I have created a video, you can refer that. You can earn a free voucher same as DP900 for PL900 also. So this was the workload, types of workload. So next topic we'll move to Azure Component. So we talked about a lot. We will do this one, we will do we will load the data, we will take from the source and all, but how actually it work? So here we see Azure Component. So how you can, so this is just an example to explain, it's not like everything, this is the only way. There are so many way to integrate your service and create a pipeline. So this is just an example. So what is happening here? So this is your source: log files, media, unstructured data, and maybe some business custom applications that I was talking about, your in on-premise applications with embedded databases and all. Then it comes to Azure Data Factory, goes then to Azure Data Lake, some data bricks. So it is a preparation and train facility. So we will talk about all this in detail, just I'm quickly going through here. And then for later you can this is Azure Synapse Analytics, that the data warehouse. There you can use some function, you can integrate it to Power BI, and using your daily data also you can directly check integrate it to the Power BI. So this is a kind of pipeline in Azure if you are creating a full end-to-end service. So let's go one by one and try understanding this segments. So as we talked, data sources. So first we have a data sources part. I'm talking about this area. So here we have talked a lot about the data sources. Here we will simply say the data which comes from somewhere else, including the blob files, the data in text format, CSV, JSON, log files, application files. So whatever the data which is not in my system, I am taking it from somewhere. Even we can if we are taking the data from some other system where it is stored in a very structured way in a relational database, but that is a outside source for me. So there we are calling as a data source. Next we have the Azure Data Factory. So now from this source we are putting all to our data factory. So Azure Data Factory is a hybrid data integration service. It allows you to create, schedule, and orchestrate your ETL and ELT workflows. So Azure Data Factory moves the data from outside of Azure to inside of Azure. So as we said, these are the outside source, and from here we have taken the data, and now we have created an ETL, extraction, transaction, and load process, or extraction, load, and then transformation. I said transaction, extraction, transformation, and load, so that we can create a ETL here. So then we'll check let's discuss little more here. So data factory activities. So activities defines actions to perform on your data. So like transformation we talked earlier, right? So let's say if source is storing the data, the names filled in two different columns, first name and last name, but we need to store it as a full name. So those kind of activities, data transformation activities, control activities, data movement. So control represent the control of the data, what kind of data you need, if you need to load some data, if you want to hold something, you want to some other things to get loaded first, and then you want, so those activities also include here. Then data factory pipeline, I was talking about the pipeline. So pipeline is nothing, just a series of work. So if just think about a pipe, so if you put 100 things, 100 is a bigger number, if you want to put 10 objects there, and if you want to move that, so you push from the back, but it's not like the last object will jump over the first one, its preceders one. So the movement will happen in a sequence. So first object will come out, then the second. It doesn't mean how much push you are applying, how much power you are applying. So in a pipe, again, if you have placed 10 objects, so if you are pushing it hard, the speed will increase, but the movement of object will always be in the sequence. And now think, that's a mandatory thing. You have to always push the objects in a same sequence. So it's all, then it's a better idea to place them in a pipe. And in here also we are doing the same thing on data and calling it out as a pipeline. So here I have mentioned, so can perform their task sequentially or perform task in parallel. So here also, yes, this is a very good line. So in parallel also, now you have one set of a process that you placed in one place, and you don't want to wait that need to be completed. Some mutually exclusive activities also you have. So you can place another pipeline in parallel, and you can move 10 more objects in same time without waiting of completing of first one. So however we have talking about the box and objects, but it's like the data, the movement of data. So ETL, a set of transformations you have defined. You want first it to come from the source and then it to go via Azure Data Factory. So that the fixed sequential process, we will call it as a pipeline. Then pipeline triggers. So now it's very important, I would say, the VBI, not only just for exam perspective, but also you should understand what is the trigger. So trigger is simple. When you hear this word for first time, what comes in your mind? Trigger, something like we just triggered. We triggered and something started. We triggered the fan switch and fan started running. So that's the one, the initialization of any task, we call it as a trigger. So when and we are specifically talking about the pipeline trigger. So normal trigger in a database and this data world, it's a different thing. Something like if you are getting some junk data, if you want some kind of a stoppage there, you want to some SNS ticket creation, you want to get some email. If you just say about trigger, it represents that activity. So here we are talking about the pipeline trigger. So an instance of a pipeline execution, pipeline can run manually, started using a trigger. So as I said, trigger is an event that causes a pipeline to run, the initialization of pipeline run. So we have three kind of pipeline trigger: schedule trigger, tumbling window, and event based. So actually we are in a continuation of discussing every single component here, but before moving to data lake storage, let's take a short break and discuss about this trigger first, because as I said, it's very important topic, not just with your exam, because you must be getting at least one question related to this. It's also important to understand the concept. So first we have manual pipeline run. So as name suggests, you have to start the pipeline run manually by executing it. So you have set a pipeline. This pipeline said, let's say I have some network folder or in some kind of a storage where my source data is coming and they are getting stored. Now I have run a ETL over that. I will take the data from there, I will put some transformation, and then I will load it to some database. So that when to start this, my incoming files, my inbound data is just coming and getting stored, and when to start this pipeline of extraction from there, putting some transformation and then loading it to my database, when to start there. So that trigger, if you are doing manually, we will call it as a manual pipeline run. So some program is there. If you are using some ETL tool like Azure Data Factory, so you have to go there, you have to run the pipeline, you have to click over run, and your process will start. Then have a schedule trigger. So schedule trigger, like let's say if you are scheduling it in automated way, so every Monday at 8 AM, so I want that at my source, if I am, let's say the first example is like OLAP, so data is keep coming from the sources, getting stored my inbound side, inbound storage, and every Monday from 8 a.m. I have said all my analysts not to do any work. You have to complete your previous work till Sunday itself, because Monday the data will get changed. So I have scheduled a trigger at every Monday 8 a.m. it will start, and it will keep running for let's say 5 hours. That depends anyway, that depends on amount of data. We have already talked about throughput in one of our videos. So throughput is just a kind of rate, the number of rows getting loaded per second, as the way we determine the speed of a bike cycle number, like how much meters per second we are moving. Similarly here we are creating a identification how much rows per second. So in a way we can say throughput. So throughput is row per second here for in our example. Throughput, there are several other definitions also, like you can define your throughput with some other performance term, but here we are just sticking to rows per second in this example. So based on that one, that make process for some time. Or let's take example like every Monday at 8 a.m. if our data is heavy loaded at, so at Friday also at 5 p.m. because I am running an organization with the rule of 5-day working. So till Friday 5 all the tasks are completed, so I'll trigger there. If it is an OLTP type workload, we can schedule it hours. So the meaning of all these examples are, we are scheduling the trigger on a fixed interval, and that interval we are deciding. So it can be per hour, for 4 hours, and in my one of, like based on my own experience, so making it in that was a insurance organization. We were supporting the backend part to create a real-time experience. The trigger was 15 minutes, just a 15 minutes. So in every 15 minutes, the job was getting triggered to load just the transaction of last 15 minutes. That was obviously that was a OLTP workload. Next we have the tumbling window. So you need to understand this in detail. Even the example that I was giving you about that 15 minutes time, that was tumbling window. So in most of the cases in current scenario, the scheduled triggers are tumbling window. Scheduled triggers, when I say, it's on time bound at a fixed time, but these are like majority of the like pipeline run designed across different organizations are tumbling window. So what is tumbling window? So what we do is, still our time is scheduled. So at that time, this time, my actual run will start, but the start time we will decide. So you can see the type of schedule tray that has a interacting properties. The setup can run on a predetermined interval, and you can set up to run in the past. What does it represent? So let's say I am running my job at job again. So job is just a sequence of tasks defined. We call it as a job. So pipeline, take example of pipeline only. So if I am running my pipeline but for a defined period, so pipeline will trigger today 5 p.m. but it will store data of last loaded data till yesterday's midnight, if we are doing this daily. So when next day, means if today is 1st January for example, so when I am running my my pipeline run is designed in a way when it will be triggered on 1st January 2 p.m. it will store from 30th December till 31st December midnight. So actually you are running in past. So you are loading the data of previous day, and whatever transactions happen recorded till last midnight, that we will run tomorrow. So here it's not like you are, when your job is scheduled at that you are picking data till that time, but you are picking the data of a defined period. So every day my job is running for at 2 p.m. but it is loading the data till yesterday's midnight. So in this way we can say we have data till yesterday, because in organization, in normal business scenario, you can imagine it may create a lot of confusion when you want to know the data of yesterday and you are loading it with the together one. However, these are not a big thing. You may have a load time and a transaction time, some flag using in your query. You can query out those stuff to check what was the total transaction of yesterday. But maybe if the yesterday's data is making some changes on the existing datas, then it might create a confusion. So it's better to use tumbling window. So that was the third kind of trigger, and it's very important, guys. So tumbling window is like the one which is really used all across. Now we will come back to our previous discussion. So we were deciding these components. So we already talked about log files and business custom app. Then we talked about Azure Data Factory, that's the ETL. Then we have a data lake storage. We'll talk about what is data lake. So data lake, Azure blob storage, we also another example here. So it's a massively scalable object storage for any kind of unstructured data. So since we the workload, we were giving the example as per the taking the reference of relational data, but this Azure components we have we need to talk about unstructured also. So from your source you are getting unstructured data as well, and your data factory is putting some kind of transformation and putting in a relational, or maybe if you want to put in a non-relational, you can store in the Azure blob storage. There you can store images, audio, video, documents. In data lake you can store blob storage. Blob again like large files, text data written over text files, CSV. Then after this part we have a Databricks. So what is Databricks? So Databricks we also talked about this one in some of the early videos, and I skipped there because we are going to discuss here. So it's a function. So it's a fast, easy, collaborative Apache Spark based analytics platform. Databricks allows you to manipulate data at large scale by linking to one data source like Azure Data Lake, modifying the data and storing in other data source like Azure. So these are the functions you are creating over some function to let's say enrich your data. In case assume from source there are some problem in your let's say amount field, they are putting a lot of what can I say, a lot of zeros, prefix zeros, that are not making any sense, or some junk values are there, some dollar mark in the name field, maybe they are storing the name as underscore maybe in or dots or something. But to get into the Power BI you need to remove those. Also if you want to visualize this data and you want to create some kind of analytics data visualization graph app or something, so you need to enrich the data. You cannot directly feed the junk data or maybe even if if your need is to store the data in that format, you are not removing or modifying them in your ETL, means in at data factory, and you are allowing them because of your need to store in data lake storages. But now for visualization and analysis, you need to remove, you need to enrich, you need to check some of the things, like also you are checking the headers are correct, if you are checking the files are not blank, if your blob file has no data, there is no meaning to run this one and load to your Synapse Analytics, or there is no meaning to store junk data in your data warehouse. So those kind of functions, Apache Spark based analytics platform, it is, you can create those functions, and then your corrected data can be directly used further. Where it can be used? So it can be used to load into here data warehouse, so or it can go to directly to Power BI. So this Azure data analysis and Azure Synapse Analytics, we already have talked. It's a fast, flexible, trusted cloud data warehouse that lets you SQL compute and store elastically, independently, with a massive parallel processing architecture. So this is a statement which I just repeated. It's a very good explanation of data warehouse. And Azure Synapse Analytics, earlier it used to be called as a SQL data warehouse. That's the main Azure crown in this data warehouse services. Post that, we can also integrate one more service, Azure Analysis Service. It's enterprise grade analytics and service that lets you grow, deploy, test, and deliver your Power BI solution. So now assume you have already stored your data in a data warehouse. You want to create some report in Power BI, Power BI visualization app, that's a Power Platform app. So here to here you can see a direct line here, because here you are already creating a function which is enriching your data so that it can be used as Power BI. But it's not a mandatory that if you are putting in the data warehouse, you are putting as per the need of Power BI. So you need to have another service on top of your data warehouse which can enrich your data. And here also you can write, if you want to create multiple reports, if you want to see multiple trends, if you want to see multiple reporting like graph or pie chart or something, so using your like the data warehouse has a lot of data, you can create those kind of things. That is what is written here: govern, deploy, test, and deliver your Power BI solution. And you can see a backward here also. So what it represent? So like from, if your data warehouse is not accepting the data which was trained by Azure Databricks, it can send back, it will do the task again, then again it will send back to Azure Synapse Analytics. Or maybe instead of going via this way, it can go like this. And in the last, hope you guys are able to understand what all these services represent and what is the purpose of it. So last thing is Power BI. So Power BI is a business intelligence tool. It comes under Microsoft Power Platform. Power Platform consists 4 applications as of now: Power BI, Power Automate, 2 more. So it's a suite of business intelligence tool that makes it easier to user to look the data. So in the very first video we talked about data visualizations. Like if you ask me, I want to see some kind of a status on my business, and if I give you a Excel file by putting 1 lakh rows, so will you be able to identify something from there? No. So that will be a kind of very hectic task to find out what is happening. So forget about Excel sheet. Directly, if you want to check that status on your query tool. So if you are a technical person, if you are aware in SQL, if you are expert, it's fine for you, even though you can get some insight from there. And if not, then you need to have an analyst who can provide you such reports. And again, my friends, that won't be much helpful to giving you any closing statements over any business requirement. So it's better always to have a data visualization, create pie charts, or pie charts, some, so many, we have a lot of services we have. It's a free tool, open source. You can go and check what kind of services you can get from Power BI. And they can use to organize and consume on web on the mobile devices. So as I said, yeah, you can install it in your computer. Also you can use it at a web. So we'll check little more on Power BI next. So here I'm giving an example. So here you can see, if you want my sales performance over different countries, and if I give you the data on row and column basis, it would be very difficult. Instead, if I create a report like this and then give you, you can directly see what is the overall percentage, what is the variance, and whatever rows that you need, whatever columns that you need. So we can create a similar record using query itself, but that will create a lot of effort, and we already have all those functions written in Power BI. So you just have to train your data, you have to ingest the data. Power BI itself will create such report. So what kind of created report, what kind of reports is generated? So paginated reports, as the name suggests, so it is designed in a way so the pages can be printed and shared. It used to be formatted to fit well on a page, like you are getting the report on a page. It contains all the data, even if it span multiple pages: invoice, sales report, profit loss statement. So these are the example of paginated reports that you should prefer if you are running a business. Then what kind of features we have on Power BI? So SQL Server reporting service we have capability within the Power BI. Power BI report builder create paginated reports. So as I remember, my friends, in my examination I had this question. So who create paginated reports? The answer would be Power BI report builder. Then a standalone tool separate from Power BI reports get published to Power BI services. So it's not just generating the report. If it is regarding your business, it's a further need. You have to share it with your client, your bosses and all. So all you need to reprint it, and print not just physically on paper. Maybe you can create PDF and share, or you can copy and paste it in your mail body. So it is designed in a way, it's just not a visualization, but it can be used for reporting, and it's an interactive one. So interactive means to say you have a way, like it's not just a rigid text. So if you want to get more information here, if you hover your mouse, it will provide you the more details of the, let's say, one particular area. So here is say United States. So you can see there is a small arrow button here. So if you click on that arrow button, this will be disappeared, and you can see only the main report. But if you click here, that is, you can get the detailed. Even there, if you want to get more details of any of the segment, just hover the mouse, it will, a kind of pop-up will be coming, and it will show you the more details. If you click there, you can get another pop-up, another window, which will define the detailed one. So it's not just a just like written on PDF or written on a paper. It's an interactive one, so is very visual, not a dump of data rows. It's interactive. So let's move next. So what is the dashboard? So you must be hearing this word many of the times. You need to create a dashboard. So what is dashboard? So dashboard is just a mixture of chart on a single page. So if we are creating a dashboard, we are creating a page which is containing, let's say, 5 kind of charts at a single page. Everything is it depends, like every single chart can represent different value or a different thing, or maybe the same object is represented by 5 way. So if you are in business of electronics, so you can create a dashboard where the first chart will present the sale of televisions, other will present sale of let's say washing machines, then sale of mobile phones. While you can even create a way it will just represent you the sale of mobile phones over the region, over the states, or over the countries, continents, or you can just simply create sale of mobile phone in just one particular country, and the representation would be different. At one place there would be a round, and there circular way, pie charts, and others. So cumulatively creating some charts on a single page where the definition is permanent, like the we have already defined what kind of data I am looking from here, we will call it as a dashboard. And it's very useful to identify anomalies. And then next topic we will discuss typical workflow in Power BI. So workflow, when we are saying the workflow in Power BI, so we are actually discussing how Power BI work. So it connect to the data source, which is actually containing the data. It pulls the data what is you need in the memory data model, edit, transform the data as you require, build reports using Power BI desktop, and share the report. So this is the actual workflow how Power BI gives you the reports. So hope you are able to understand. There is nothing much to explain here, just it is give here I just explain the kind of pipeline, let's say pipeline, since the sequence of work how Power BI is working. So first you need to connect to the data source, then pull what is you need in your data model, then edit, transform if required as per your requirement, and then build reports using Power BI desktop, and then reports will be generated and shared. And now we will discuss about the last topic of the day. So this is additional point just I have added because I got some inputs from my colleagues that they are getting questions in the AZ 900 examination about the role of data engineer. So who is data engineer and what actually it do? So I've just added a additional topic here. So Azure data engineers are responsible for data related implementation tasks that include provisioning, data storage services. So provisioning is setting up the servers. We already talked in the core concepts one. Ingesting, the streaming and the batch data. Ingesting means sourcing our inbound data that we need from our source systems. Transforming the data, implementing security requirements, implementing data retention policy, identifying performance bottlenecks, accessing external data sources. So data engineer role, or better to say Azure data engineers, are the one who do the provisioning, means setting up the servers, they are doing the ingesting the data, means sourcing the data, doing the transformation, and then they are also implementing the security. So my friends, Azure is very secure. They have implemented a lot of security features. They are available when you are setting up your database, when you are creating a full services, or you are creating your resource group. You can opt for a very detailed security feature as per your requirement, and for that again you can have one dedicated certification called SC900. There you will learn about the security features and security services given by Microsoft. You can also get a free voucher for that. For that you need to refer the same video which I am referring multiple times, how to get 100% discount voucher for my 5 Microsoft certifications, and the link is all given in the description box. Anyway, coming back to the discussion, also implementing data retention policy. So data retention policy, like till how much time you need to store your data. So do not get confused with the data warehouse and all. So setting up a data warehouse, running storing it there, also striking out 30 days back data, 10 days back data, keeping putting them in data warehouse, all comes under data retention policy. So when you are doing such activity, you are actually creating a data retention policy. Then identifying the performance bottlenecks. So one point we already have talked about, but we didn't go in detail, that is the performance part. So if you are creating a pipeline, you are setting up your services, you also have to think about the performance. So we just have talked about OLTP, OLAP. There also we thought, so if we do the OLAP from the same database, it will decrease the performance, since it's all about you have to increase your compute powers. So it's also not a good idea just to get service of a lot of compute powers while your actual transaction count is very less. So instead of increasing in compute powers, it's also better to create a plan, a policy in a way that your OLAP is different, your data warehouse is different. You don't need older data, but you need to just have a history, then move them out into the data warehouse and all. So if that is not happening, still you are identifying my performance is not good, throughput is not good, you have to identify those bottlenecks. You have to if you are a data engineer, if then what remediation is required to get over that, and accessing the external data sources. So yeah, so if we are ingesting, we need the access to our external data sources. So these all are the roles of data engineer. So for this with this statement, I can say we are covering everything which falls under the syllabus of Azure Data Fundamentals, and now I would say you are prepared for DP900 certification exam if you were able to catch every single terminology here. And I hope the way I have curated and tried explaining the terms, it was useful. It is useful. You have learned a lot of things. Still you have a doubt, you can put that in the comment box. I'll try explaining that. If you need further learning, the best place I would say is the Microsoft pages. They have created a detailed page in a very simple language for every single terminology, every single their service, every single their core concept. So that falls under many, like for example, if you are writing IAS, PS and SAS, so this is a common syllabus for AZ900, DP900, but they are not defining it as a certification, but as a knowledge basis. They have written a very well page that I have shown you in the previous page also. And how to get that? Simple, go to Bing, go to Google, just search it. If you are not getting the right page, so in most of the time you will get that suggestion at the first one, But if you are not getting, then write Microsoft Azure together with your question. If you want to see, let's say, what is provisioning, so provisioning Microsoft Azure, you'll get a page, you can learn from there, and that would be the best place to run it. So with that, I'll say, if you are attempting DB900 certification, all the best, friends. And in future also I'll be creating more interactive and nice course materials. Please share my videos to all of your friends, colleagues, subscribe to it, so that I can keep generating such stuff. It take a lot of efforts, my friends. And again, all the best. Thank you.